Welcome to E-Content Development Center, Majlis Arts and Science College, Puramandur. Myself, Muhammad Rafi, HOD, Department of Physics. In this video, we will discuss an inverting operational amplifier and a non-inverting operational amplifier. After watching this video, you will understand how an inverting operational amplifier is working and how a non-inverting operational amplifier works. Amplifier produces an output which is out of phase with the input signal by 180 degree. Here we can see two pictures, input signal and output signal. Picture shows the relation between input and output, that is just reverse the input signal by output, that is input signal and out signals are out of phase. This is the circuit diagram of inverting operational amplifier. In this picture we can see the two inputs, inverting input and non-inverting input. Negative sign indicates the inverting input and positive sign indicates the non-inverting input. Here we apply input signal Vi at inverting input through a resistance Ri. The output is feedback through the feedback resistance Rf. Here I is the inputs current passing through the resistance Ri. I1 and I2 the two input currents. Vo is the output. The potential drop across resistance Ri is the Vi minus V1 and potential drop across resistance Rf is the V1 minus Vo. The mathematical expression for gain AV is equal to Vo by Vi. For an ideal op amp, I1 and I2 are 0 because input impedance of an ideal op amp is infinity. So II is equal to If. Feedback current and input current are same. Also we know that for an ideal op amp, the voltages at both inputs, that is at inverting input and non-inverting input are equal, that is V1 equal to V2. But V2 is 0, that is non-inverting input is grounded, therefore V1 is also equal to 0. Then the above equation becomes Vi minus 0 is equal to If Ri and 0 minus Vo is equal to If Rf. From above two equations we can get minus Vo by Vi is equal to If Rf divided by If Ri. So the voltage gain of the inverting operational amplifier is given by AV is equal to minus Rf by Ri. This indicates that the voltage gain of the inverting amplifier is decided by the feedback resistance and input resistance, that is AV is equal to minus Rf by Ri. The negative sign indicates the phase reversal. Next we will discuss non-inverting operational amplifier. For a non-inverting operational amplifier, the signal is applied at its non-inverting input. The input and output are same phase. The amplified output is in phase with the input signal. This is the circuit diagram of non-inverting operational amplifier. In this picture, Vi is applied at non-inverting terminal. The feedback resistance is connected to inverting input terminal and resistance R2 is connected to ground from inverting input. From the circuit diagram, V1 is equal to If R2 and Vo is equal to If into R2 plus Rf. So the gain AV is equal to Vo by Vi, which is equal to Rf plus R2 divided by R2. So AV is equal to 1 plus Rf by R2. From this expression we can see that there is no phase reversal, that is there is no negative sign. The gain of the circuit is 1 plus Rf by R2. I hope you understand the topic and thank you for watching.